Alright guys, today we're going to learn how to solve quadratic equations using the square root method. Okay, the square root method is pretty important, but first of all, let me show you what we mean by solving the quadratic equation. So consider the graph that we have here. If we were to graph this function, which I'll do it for you right now. Alright, so you saw the graph. The graph looks like this. It has 9 units going up, so 2, 4, 6, 8. I'm sorry, it has 8 units moving in the y direction, so 2, 4, 6, 8. Okay, and the graph kind of opens down because a is negative, right? A is negative, the graph opens down, and it crosses the x-axis at these points, as you can see. So those are what we call the x-intercepts. So we want to identify the x-intercepts for this graph, which we could, right? That's easy. It's -2, 0, or 2, 0. So let me write that down for you. Like if I were to find the x-intercept, it would be -2, 0, and 2, 0. Graphically, that's how we find the x-intercepts. Now the problem is, if we have to graph it every time to find the x-intercept, then it takes a long time. So we want to develop ways to find the x-intercept that's more efficient. But before we get started, I do want to kind of write down a few more terms which also refer to the x-intercept. So sometimes they'll call it the x-intercept, other times they'll call it the solutions, okay? Whenever you see the word solve, that's what they're looking for. They're looking for the x-intercepts. Whenever you see the word like roots, okay, roots of a quadratic, then they're referring to the x-intercept. So the most common word that you're going to see, it's solving. Another one that it's out there is the word zeros. They're looking for the zeros of the solution. They're looking for the x value that makes the y value 0. So that's what we mean by 0. So there are 4 different alternative words that also means the x-intercept. Okay, so the main goal for today is how do we find the x-intercept without graphing. So one way to do that is we use the square root method. So let me walk you through a problem, the same problem actually, using the square root method. There are about 3 steps. So the first step is you must set the letter y equal to 0. So it's going to look like this, okay? So 0 equals to -2x squared plus 8. So that's setting the letter y equal to 0. Step number 2, we're going to go ahead and isolate the term x squared. Okay, so make sure we want to try to isolate the term x squared. So let me go ahead and copy over the problem. Okay, the problem looks like this. I'm just switching the size, and that shouldn't change anything. I'm going to go ahead and isolate the term x squared. To do that, I have to move the -8, and then that gives me 2x squared equals to -8. And the last thing I got to do is I got to divide both sides by -2. So go ahead and divide by -2. Okay, and that will isolate the x squared term. So once I have isolated the x squared term, the next step is to square root both sides. Okay, to square root both sides. So once I finish this step, it's going to leave me with x squared equals to 4. Okay, and I am going to square root both sides. So here's what I mean by square rooting both sides. I am going to, like this, that's square rooting both sides. Now, when I square root x squared, which is something we learned a couple months ago, this is going to leave us with the letter x. And then when we square root the number 4, we have to be very creative here. So ask yourself, what number squared is 4? And you're going to see that there are actually 2 numbers. 2 squared is 4. negative 2 squared is also 4. So technically you have two answers, two different numbers squared equals to 4. So therefore your answers are 2 and negative 2. Now if I go back to the graph, you can kind of see that this is negative 2 and this is 2. So those are, as you can see, the x-intercepts. And the only thing you have to do is you have to put them in order pairs, like negative 2, comma 0, 2, comma 0. Okay, very good. So that is the square root method. And remember that it comes with a variety of different names, okay? So, but they all mean the same thing. All right, so let me take you through a couple more problems solving using the square root method. I'm not going to write down the steps again, but you know the steps. Okay, there are 3 steps. So here we go. So the next problem, the first step, I am going to set y equals to 0. But remember, there's no y. So therefore, I can skip step number 1, right? Okay, step number 2, I got to isolate x squared. Okay, so my problem is x squared minus 16 equals to 4. To isolate x squared, I have to add 16 to both sides. And now I got x squared by itself. Okay, let's move on to a third step. So we go over here, and then our third step is going to be to square root both sides. Okay, so we got x squared equals to 20, and then I am going to square root both sides here. Okay, square root both sides. This is going to leave me with the letter x. Okay, now we need to simplify the radical. We learned how to do this a couple months ago, right? I know it might have been a long time, so you might have forgotten how to do it. But remember, what is the largest perfect square that divides into 20? And that would be 4 is the largest perfect square that divides into 20. So 4 times 5 is 20. And then remember that the square root of 4, what number square is 4? Well, that's 2. So 2 gets to go outside. Okay, and 5 is still under the radical. Now keep in mind that there are always going to be 2 answers when you're dealing with radicals, because every number has 2 different square roots. Okay, so you're going to get plus and minus 2 radical 5. So be careful with that plus and minus. All right, quadratic functions will tend to cross, most of them cross the graph at 2 points. So therefore there are 2 solutions. Great job. All right, last problem, number 3. Solve using the square root method to find the solution. So the first step is to set y equals to 0, but again, this one doesn't even have a y. So technically there are only 2 steps for problem 2 and 3. Step number 2, isolate. Now in this problem, we don't really see an x squared term, but we see this as our x squared term. So we want to isolate that, okay? So let's go ahead and write down x plus 1 squared minus 49 equals to 0. And in order to isolate that, I got to add 49 to both sides. So add 49 to both sides. This leaves me with x plus 1. Let me use a different color. This leaves me with x plus 1 squared equals to 49. And then I am going to move on to my third step. So I'm just going to continue with the third step right below the second step, okay? So I am going to now square root both sides. So like this, like that. And then just put a plus and a minus in the front because there are 2 answers. So you have, when you square root something square, you just get the number before the square. So you get x plus 1 equals to plus or minus 7. Okay, and then you're solving for x, so therefore you're gonna go ahead and add, subtract 1 to both sides. So I'm gonna subtract 1 here. Okay, so that's what I mean by subtracting 1, as you can see, right? So what do we get? Think. We're gonna use common sense here. So like negative 1 plus 7. Okay, well, negative 1 plus 7 is 6. So that's one answer. Okay. What's another answer? Well, the other answer would be negative 1 minus 7. Negative 1 minus 7 is negative 8. Okay, solving using the square root method. Great job, guys. I'll see you guys in the next video.